So our first lesson in chapter 2 was section 2.5, and we did algebra problems that we applied properties to. And the idea behind that was to get you used to the idea of justifying everything that you do. So what we're going to do today is we're going to start the process of doing an actual geometry logical reasoning. So it's 2.6 through 2.7, proving statements, day 1. And our objective is to write a general reason for a specific example. So our goal is to write a general reason. We're going to be given a specific example. Whoops, I forgot the date. Today is September 14th. Okay. So we have a series of definitions right now because we need to get some out of the way. I will tell you, go ahead and cross out set 1 because we did not get a second set in here. This was long enough on its own. So deductive reasoning is reasoning based on a fact. And a lot of times I'll say based on a rule. A conditional statement is a logical statement with two parts, a hypothesis and a conclusion. There is a cause and effect. The synonym is contingent. What's going to happen is contingent on what you know first. So for example, if it is raining, then I will take my umbrella. So the hypothesis is we need to test to see if it's raining. If it is raining, so we're going to test that hypothesis. Is it raining? Look outside. Yep, it's raining. Then the conclusion is that I will take my umbrella. So the rain causes the taking of the umbrella. It's very common that a conditional statement is written in if-then form, but it isn't always. We're going to practice if-then as much as we can, though. So a conclusion, because remember, a conditional statement has a hypothesis and a conclusion. A conclusion is the result of logical reasoning. It's the result. And if I ask you to conclude, that's a verb. That's for you to decide by deductive reasoning. So if I say, give me a conclusion, then that's a noun because you have done an action, you've concluded. Okay, so a postulate, we already know this one. It's a statement or rule that is accepted without proof. Remember, the mathematicians got together and said, yep, it works that way. Nobody has to prove it. We all agree. Whereas a theorem is a statement or rule that must be proven prior to knowing it is true. So a lot of times you don't know the difference between them by appearance. They both will be if-then something. But a postulate is just historically called a postulate because nobody had to prove it. All the mathematicians went, yep, we agree. And a theorem had to be proven, like the Pythagorean theorem. Pythagoras believed that that's the way it worked for every right triangle. Other mathematicians are like, no, you need to prove that that works for all right triangles. So we're going to learn a new list of theorems today. There are 6 of them, but they're really pretty closely related. The first 3 are all about segments, and the next 3 are all about angles. And you'll have seen the words reflexive, symmetric, and transitive before in the case of properties. So these are related to those, but we don't call them properties because we're not going to talk about their measures. So the first one says, congruence of segments is reflexive. So if you have a segment that is congruent to itself, then why can I say two segments are congruent, or why can I say a segment is congruent to itself? Because there's a theorem that says congruence of segments is reflexive. Okay, congruence of segments is symmetric. So remember that that would be a situation where you have two segments that are congruent. So let's say segment MO and segment DC are congruent. Symmetric indicates that they would still be congruent if you just switch the order. So segment DC is congruent to segment MO. Congruence of segments is transitive. So let's say segment PQ is congruent to segment RS, and segment RS is also congruent to segment XY. Well, just like the transitive property, there's a duplication that's going on, and that's going to tie these two statements together. So segment PQ is congruent to segment XY. But again, one more time, let me say this so that you're really clear about it. They may look like the properties of the same name, but properties apply only to measures. Okay, so if you see what looks like the transitive property, but it's not measures, it's incongruent instead, then its congruence of segments is transitive. Next, we are the same, it's just pertaining to angles instead of segments. So again, we have reflexive, symmetric, and transitive. So congruence of angles is reflexive. So angle ABC is congruent to itself because there's a theorem that says that can happen, and the theorem is congruence of angles is reflexive. Congruence of angles is symmetric. So let's say I have angle D and it's congruent to angle O. Symmetry means that they're the same if I flip them or not. So angle O is congruent to angle D. And I can't just do it because I want to. I do it because there's a theorem that says that can happen, and that theorem is called congruence of angles is symmetric. The last one is congruence of angles is transitive. So let's say angle 1 is congruent to angle 2, and angle 2 is also congruent to angle 3. Then because of this theorem, congruence of angles is transitive, angle 1 is also congruent to angle 3. Okay, so why did we go through those? Because remember, I've been telling you, you have postulates and theorems and definitions that you have to know. And our goal today is to write a general reason for a specific example. So general reasons are actually the postulates, the theorems, and the definitions. So the more of those we know, the better we can justify what we're doing. Okay, so what we're going to do today is put a specific geometric statement to a general reason. So you will be given specific statements and its conclusion. Your job is to write a general conditional statement. And so I will be asking you, what's the reason? I won't keep asking you, what's the general conditional statement? I'm going to say, what's the reason? And remember, your reasons should end up being some postulate or theorem or property or definition. So keep your notes close at hand. But if you use the trick, even if you don't know the postulates, theorems, properties, and definitions, if you use this trick, it will do it for you. Okay, so very specific. This is very specific. Why do I call it specific? Because is every angle on the planet called angle A? No. Is every angle on the planet 67 degrees? No. This is a very specific scenario. So what general definition or postulate or theorem goes with it? Well, let's take what we have specifically and talk about it in generalities using pronouns and things like that. Okay, so first off, what is this? This is an angle. How many angles do I have? I have one. So if an angle's measure, because that's what I have one angle's measure. If an angle's measure is less than 90 degrees, so that's all of this, then what happened to it? It turned out to be acute. And what did we just write? We just wrote the definition of an acute angle. And I didn't even have to know that definition by memory. I've written it by taking something very specific and describing it out generically speaking. Whoops, spelled general reason wrong. And this one happens to be the definition of an acute angle. Okay. So remember, you are more than welcome to take the time, to pause the video, go back and watch the video, and I have put it in writing so that you can't say that you didn't hear it, or maybe you didn't, but now you can see it. You must know all the definitions, properties, postulates, and theorems. If you don't know them, please keep your notebook, well, you don't have a textbook, your notebook close at hand. But again, if you just use the trick that we're going to talk about here a couple more times, then you should be fine. Okay. So here's our example, specific geometry statement to general reason. And I'm telling you up front, these two are definitions. So if you wanted to go look them up, you could in the definitions that we've learned over time. But again, if you just do the trick, you don't need to worry about that. So what do you have? You have segments. How many of them do you have? 2. What's true about them? They're congruent. So if 2 segments are congruent, then what's happening? And this is where the pronouns come in, because we don't have to say the word segments again. Okay, so then they, there's my pronoun, they or their, because in this case we're going to talk about their change, their measures are equal. Okay. So if 2 segments are congruent, then their measures are equal. And look at that. We just wrote the definition of congruent segments. Okay, number 2. What do you have? You have an angle. How many of them do you have? 1. If an angle, or you can say if one angle. Well, what's true about that one angle? It is a right angle. So if an angle is a right angle, then what's happening? Then, and I'm going to use pronoun, it's, you can say then the angle, but then its measure, because that's measure, its measure is 90 degrees. Okay. If one angle is a right angle, then its measure is 90 degrees. And oh look, we just wrote the definition of a right angle. Okay, so remember how I told you they were definitions, so you could have looked them up in your notes, but if you use the trick, you don't have to do that. Okay, So the next one says use a postulate or theorem as the reason for the conclusion. So you can look up your postulates and theorems, or again, use the trick. So what do we have? We have angles. How many of them do we have? We have 2. So if 2 angles. And if you want, you can use the symbol instead of writing out the word for angles. So if 2 angles are vertical angles, and again, you can use the symbol or you can write it out. So if 2 angles are vertical angles. You can't say if vertical angles, because that doesn't even make sense in English. So if 2 angles are vertical angles. If the horses are palominos, you don't say if the palominos. Okay? So if 2 angles are vertical angles, then what's happening to them? Then they are, what's the symbol? Congruent. And if you wanted to use the symbol instead of write the word congruent, you could do that. So if 2 angles are vertical angles, then they are congruent. And that's a theorem that we learned back in chapter 1. Okay, number 4. I would like you to pause the video and try number 4 on your own. Please try number 4 on your own. Pause the video and try it on your own. Okay, welcome back. So you have 2 angles. So if 2 angles form a linear pair, remember the abbreviation for pair is PR, so you could just write that if you wanted, comma, then, and here they are again, then they are supplementary. If 2 angles form a linear pair, then they are supplementary. And that was a postulate we learned in chapter 1. Okay. This theorem is not in if-then form. So the only theorems that we know that aren't in if-then form, we learned today. So these last 2 examples are one of these 6 from the front. So let's look at what we have. We have two different segments that are congruent. They're still congruent, but they've been flipped. So they had symmetry. So congruence of segments, because that's what these are, is, I know some of you are going, why isn't she saying are? Segments is plural, because if I remove of segments, then congruence is. That's where the is referring to the congruence. So congruence of segments is symmetric, because we had symmetry going on because they were flip-flopped. So number 6, I have 2 angles that are congruent, and I have another 2 angles that are congruent, but I have a duplicate that isn't showing over here. So I had 1, 2, 3 angles that came down to 2. So that's that transitive thing. But these aren't measures, so I'm not going to put transitive property. They're congruent angles. So congruence of angles is transitive. Congruence of angles is transitive. So unfortunately, because these don't come in if-then form, since 5 and 6 do not come in if-then form, the trick doesn't work. They're just some theorems that you're going to have to memorize. Okay, so kind of like the properties are not written in if-then form either, you just kind of have to memorize them. Please make sure if you have any questions to email your teachers and they'll get back to you. You'll be taking a test on this, the 2.5 from last week and all of this week. You will be testing on that next week on Tuesday of next week.